That's the one we did on Friday. Okay, exponential functions. So we're going to talk about e to the x now. Let's review. Where did the natural log come from? Be more specific, Kev.
Log base e.
Yes, that's a good pre-calc / advanced algebra explanation. But from a calculus standpoint, where does natural log come from? Nothing? Oh, Andrew Jackson. Andrew Jackson, correct. No, that's E. Where does E come from? What's that?
Isn't it like the derivative of 1 over x or integral?
No, the integral of 1 over x is natural log x.
Okay.
Sam?
Isn't it the area under the curve
That's natural logs
from 1 to, or where the 1 to e is 1?
Good. Perfect. So E is the number such that when you take the area under the curve, what curve, by the way?
1 over x.
1 over x, you get an area of 1. Okay, so where does the natural log come from? No?
Isn't that like the derivative of 1 over x?
No. Close. It's the integral of 1 over x. But why is the natural log the integral of 1 over x? It's because we needed a way to express 1 over x. You'll recall that when I presented you with that quick problem up there, I just said, here, find the integral of 1 over x. And we ran into problems because you end up with 0 in the denominator for the constant. So mathematically what we did is we needed a way to express the area because we know there has to be an area there, so we created a new function which was natural log. Okay. So we know what e of x is. What we haven't done yet is we haven't taken the derivative or the integral of e of x, e to the x. Okay, we've talked about natural log, where the derivative of natural log is... Hello? Hello? Is this mic on? Hello? Testing, 1, 2. Derivative of natural log is 1 over x, and the integral of 1 over x is natural log. Good. Okay, so today we're going to talk about natural exponential function, also known as e to the x. We're going to differentiate it, we're going to integrate it, and then of course today, be kind whenever possible. It's always possible. Anybody know who said that?
Martin Luther King.
No? Good guess. Good guess.
Darth Vader.
No? Yeah, that was Darth Vader, right? He was slaughtering.
Batman.
Batman did not say that.
Malcolm X.
Malcolm X? No.
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 I did. Oh, I say that all the time, but I'm not the originator of that statement.
Abe Lincoln.
Abraham who?
Lincoln.
No.
Andrew Jackson.
Good guess. Not. Yeah, Gandhi's probably the closest guess so far. Nope. That's another good guess. One of fitting into that motif.
Marcus Garvey.
Who? What did you just say? Did you say Garvey?
Yeah.
No.
T. Washington.
Oh, the Dalai Lama?
The Dalai Lama is correct.
Oh. I knew it was
All right. So,
No, I didn't.
aside from how we define e to the x as being the number such that, as Sam explained, the number such that when you take the integral of 1 over x from 1 to some number, you get an area of 1. It also happens to be the inverse function of the natural log. So here's the natural log function that we talked about. Passes through the point 1, 0. And you'll recall graphically, the inverse of a function is the reflection of that function over the line y equals x. So that 45-degree line that comes through there, you reflect that over, you get e to the x. So if the natural log of x passes through 1, 0, then e to the x passes through 0, 1, which makes sense because any number raised to the 0 power is going to be 1, the exception being 0. 0 to the 0 power is not 1. Completely irrelevant. What can you tell me about that function from a calculus standpoint? Sid, what do you got for me?
It is increasing.
Beautiful.
And
Always increasing over the entire interval. Good. And it's concave up. Anything else?
Well, it crosses the y-axis.
It does. It has a y-intercept at 1. Does it have an x-intercept?
No.
No, it is asymptotic to the x-axis.
Yes.
It's a word. Yeah. What's the limit as x approaches infinity of e to the x? Kat, feel free to chime in if you'd like. Since you are a resident limit expert.
I would.
Oh, it does. What happens is I go very far to the right of the darker function.
If it's positive.
Yeah. Positive infinity, good. And what happens if I take the limit as x approaches negative infinity? I go very far to the left.
Negative.
Zero.
0, correct.
Oh, okay.
Yeah. Good. Because again, it's asymptotic to the x-axis. Okay, beautiful. Nothing exciting there. Here's the exciting part. Yeah, okay, so we can test that. Yeah, we did that already. Great. Little pre-calc review. How do I solve that problem, Mary?
Natural law. Take the natural law, and then
Be more specific.
Oh,
Natural
of
log of
both
what?
sides.
Of both sides, good.
and then subtract the 1.
Okay, take the natural log of both sides. What's the natural log of e to the x plus 1?
X plus 1.
Good. And what's the natural log of 7?
Natural log is
Yeah, I don't know. Natural log of 7, so we'll leave it in that form. Good. We get to that, and then done. Okay. And if you don't know what a natural log value is, that's fine. Some of them you should know. And you should know what the natural log of e is. You should know what the natural log of 1 is, that kind of stuff. But natural log of 7, there's no reason why you should know that. That's the first trick that you should remember from pre-calculus. The second trick that we've talked about, which I don't think I have an example of, is the E2 trick. Raising both sides to the e, or putting both things as the exponent for an e problem. Use that commonly to solve natural log problems. Greg's question?
Yeah, it's for showing your work. The second part where you have the ln on both sides, is that step necessary to show? Or can you skip from the first to the third line?
The second step is more important than the third step.
Okay.
Because you have to show the mathematical process you went through to jump from there to there.
Okay, thank you.
Okay, and if you wanted to know, you could plug that into your calculator if it is a calculator question and you're asked to do an approximation. Remember 3 decimal places. Okay, so this is all the stuff that Sid already told us. It's concave up. It's domain and range, that's concave up. It's always increasing. It's 1 to 1. And then we talked about the limits. Well done. Question in the back?
So when you take the natural log of 7, what exactly is it evaluating?
You tell me.
I'm confused.
How did we define the natural log?
The area, well, 1 to e, the area under the 1 over x graph is 1. So, I can't put it together.
Okay. You let me know. Okay, you'll get it eventually. And if not, I can help you. Here's the cakewalk. The derivative of e to the x is e to the x. Wait, there's a trick. It can't be that simple. There's no trick. That's it. Okay. Well, there's one thing you need to remember, in that if it's e to the u, you've got a little different thing there. Okay, so this is easy. Stay there. That's its own derivative. The only trick is if you do e to the u, you got to remember to chain on. That's it. So if it's its own derivative, then what's the integral of e to the x? E to the x. But no chain rule in e to the x, so we'll have to talk about how to handle that in a second. Yeah, thank you. Let's see. Okay. What's that? Casey, are you mumbling?
Yeah,
What'd you say?
e to the 2x minus 1. It was easy for e to the x, then why not make it the same?
It's not quite that easy.
Yeah, that's it. I thought it was that easy.
Yeah, not that
It's
easy.
just e to the x.
Yeah.
It just either.
Just e to the x. No matter what it says, just e to the x.
Too much problem with e to the x.
What'd you forget?
That, gotta have a d something over dx after,
The
Also known as?
derivative sign.
Not quite what I was looking for, but
numbers, letters.
not a false statement.
Oh, I've heard it.
What did you forget?
du dx.
Good. What is du dx? What does that mean? Don't tell me what the answer is 2, but what does that mean?
Whatever is in the u, whatever's in the exponent,
What about whatever's in the exponent?
put it there.
No, because that would then just be u. Help it, Brennan.
You use,
Take the derivative
Bingo.
you
Du dx is a derivative of u.
Just put it there.
Also known as?
The derivative sign.
Friday yet?
You substitute. It's horny.
So what happens when you take the derivative and then you have to take another derivative of part of that?
Chain rule.
The chain rule. That's all this is. Holy guacamole. So we took something simple and made it more complicated. All right, so finish that case.
give me a second, I'm coughing more.
Choking on your own spit. You okay? You want to go get a drink or something?
Yeah, I'll take a
All right, go ahead.
We'll wait until you get back.
While you're dying, don't forget the meds. What should go on the end of this? 2.
Whoa.
What about that one?
Oh, I thought that was the answer to that.
No, that's not the answer.
How did you get
It's a
it?
different problem. I said it was easy, but I lied. Anytime you have 2x minus 1, it magically becomes negative 3 over x.
It just happens.
What's the derivative of e to the anything?
Yeah.
Let's try that again. What's the derivative of e to the anything?
X dx.
E to the anything. And chain on? Chain on what? Which is what, John?
Oh god.
U prime over U. Wait, is, oh, what would that be?
1 over x.
Put your hand up, Grace. You okay?
Yeah.
All right, good.
It'd be like,
Yeah. Sloppy natural log stuff.
Can we not take the derivative of that? I'm sorry?
3 over x squared.
Good, 3 over x squared. Well, yeah, 3 over x squared. Why, Mary?
Because you bring the x to the top, and then it's -1, and then you multiply -1 by -3, which makes it positive. And then you subtract 1, which makes it -2, and then bring x left.
I'm just gonna be weird and move it out in front. All done. So part of the problem that we're running into now is not the new material we're covering, but that's a perfect example of problems that many of you are having. Having finished the quizzes, the frustrating thing is not that you don't know how to do logarithmic differentiation, it's that you're doing things like taking a derivative and putting a plus c on there. That just absolutely cannot happen. Or you're taking a derivative and using a u. We've never taken a derivative using a u. There is no u du for derivatives, those are for integrals. There's no excuse why you shouldn't be able to take the derivative of this. And that's what's bogging down a lot of you. Not the conceptual stuff about taking the derivative of e to the something, it's the fact that you don't know how to take a simple derivative. -3 e to the -1, and do that. Need to clean a little bit of that up or things are just gonna get worse. Like we said, if it's its own derivative, then it's also its own integral. It's its own integral. Which is easy if you have e to the x, but all of a sudden we're going to have things that aren't e to the x. We're going to have e to the u. And since we're taking integrals now, it makes sense to do a u to u, depending on the problem. Okay, we good here? Question?
Is the fundamental theorem of calculus still the same for the variable switch for e?
Doesn't matter. Yeah.
E,
I mean, e's not a variable, so you
Yeah,
wouldn't be
so-
replacing e, but you'd replace the u.
T or u.
Yep. Yeah, that whole fundamental theorem of calculus doesn't matter. It doesn't care what function
Doesn't
you're
change
dealing with.
natural logs, okay. It's fundamental.
Common mistake that's going to happen to a good chunk of you is you're going to tell me that the answer to that problem is e to the 3x plus 1.
Let's see.
And obviously, if I just explained it as a mistake, that's not the case. This has to be done as a u to u problem. What's u? 3x plus 1. So what's going to happen is you're going to miss that 1/3, which becomes a very important term there. Now we're good to go. What's the integral of e to the u? E to the u. So 1/3 e to the u. We can sub that back in. 3x plus 1 and plus c since it's an indefinite integral. So many of you will lose that constant term that becomes so necessary. Also, you'll see problems where you'll have terms in front of it. So for instance, if that was a 3x squared, I would need something to cancel with. Otherwise, it's undoable, or you have to use some tools that you don't know about, like integration by parts. Question?
Yeah, would you have to multiply the c by 1/3 as well? Because, like, I wasn't sure if there'd be parentheses around the e to the 3x plus 1 plus c because
What's c times 1/3?
c over 3?
Nope.